The theme of this episode is running into problems. Let's go ahead and get a counter down here so we'll keep track together as we go through. But hey, half the fun of building something is finding solutions for all the problems you've created for yourself.
Oh no. You always look at me for starting. Just say hello.
Hola. It's not really like the beginning of the episodes.
Are we halfway through?
I think we're halfway through.
I don't know. You edit, so I don't.
I think we're halfway through,
Oh.
but we'll see when the editing happens. Whoa, wait a second. Why do we think we're halfway through this episode? This episode clearly just started. Introducing problem number 1. So the footage of us opening the motor, the pulleys, and the belt, poof, gone. Don't know how. Does not exist anymore. So what you missed, let me fill you in real quick. We opened up the motor controller, the pulleys, the belt, and the power supply. We attached the small pulley to the motor and the large pulley to the drive shaft. You remember the bore for the large pulley is 24 millimeters and the diameter of the drive shaft is 25.2. So what you missed was a bunch of us grinding and hammering the large pulley onto the shaft. Trust me, you didn't miss much. But hey, now you're all caught up. Problem number 1 solved. Let's get back to it.
We got more stuff.
We did. It's another day. We got more stuff. We're working on it.
Took a long time to open. Power.
24 volt power supply. It's going to take our 110, put it in the 24 volts. We'll send that to the motor controller, send that to the motor. That'll spin the arm.
We started perforating these bags.
Yeah.
Fuse.
5 times 20 millimeter glass fuse holders. So we're going to put slow blow glass fuses in there. We don't know exactly the amp rating on them yet. We'll do the math on it. You gotta like know the normal operating range and then times it by like 150 or something like that. I don't know. I'll look it up. And these?
Bojack.
Mojack.
Oh, gotcha. Fuses.
Yeah, these are slow blow little glass 5 by 20 millimeter fuses. Slow blow, so the initial spike in current doesn't kick the fuse.
Oh, okay.
We got an assortment of different amperages because we don't know exactly which ones we'll need yet.
Okay. I guess we'll start grinding.
Yeah, let's do it. Get this nice and smooth. Put the motor on it.
And then put the motor on, and then
make the belt between the pulleys of the motor. Wire the motor to the motor controller to the power supply to the wall, and then put fuses to protect the motor and everything else. So the fuse will be after the power supply, before the motor controller, after the motor controller. We'll figure that out. Depends on what we're protecting. I think we're trying to protect everything. So, all right,
let's grind. Brace yourself. I don't know which way we're going.
Is it working?
Yeah, it's going.
I know, it's pretty cool. We got a casualty for the grinding sparks. Dang, bro. Yeah. That's pretty good. Pretty smooth.
The top is a little
high.
Yeah, like the very top of it.
So it's gonna angle it some.
Yeah. Still a little off.
Yeah, we're trying to get these parallel and it can rock. So we're trying to grind it as flat as we can to get it to where it's parallel to the drive shaft. Okay, so we could just shim here.
Yeah, I think so.
Okay, all right, sounds good. So I guess let's line it up best we can and then mark the spots, then drill and tap.
Mark the spots and drill and tap.
So the motor mount has little slots in it. So we're gonna mark those, drill and tap after we line it up with the shaft the best we can. How's it look?
Like shit.
We can see the points. All right. So
yeah, as long as they're inside these markings.
Okay, so we'll go like center of those lines somewhere.
Yeah.
Drill and tap. Cool.
Tippy tap. All right, now we're gonna.
Now you gotta set this whole thing up and drill and tap those holes.
Ooh, I don't know, man.
Don't think it can fit under there? Oh, that's bottom, huh? Oh no.
I do not have a drill bit that short.
We're gonna have to drill and tab it by hand? No, okay, no, wait a second. Excuse us. Sorry, guys, our brains are small.
On my tool.
So I was like, leave me out of the small brain. Your tool, you jacking up. All right.
So you can just edit all that. I'd be like, oh, look, it fits.
It fits, no problem. We never even thought there was a possibility it wouldn't. Let's punch it. You mark your spot. You line it up with a center punch. Give it a little and it leaves a indentation in the metal. And then the drill bit tip will stay in that indentation. And then it'll keep it from walking all over on you. Just like that.
Nice.
Pretty satisfying too.
Kind of
Knocking those
was.
little indentions
It
in
kind of
there.
was.
Is that the right size drill? There's like a chart that lines up the drill to the tap. So yeah, we gotta make sure our tap is right for our nuts to our bolts.
My nuts.
We're busting out the drills and the taps and the, which one is that?
M6.
So we just screwed our screw into the M6 die just to verify that it is an M6. And it is. So that means we can use the corresponding M6 tap. This is not a bottoming tap. Will be good enough though. We're gonna go deeper than we need to go.
What she said.
Oh shoot. So the 6 mil tap calls for a 5 mil drill bit. We don't have metric bits, so 3/16 is slightly under 5 mils. So we're gonna try that first. But we're thinking with the wobbly old drill press, will probably wallow out to 5 mil anyway.
Let's test it.
Oil, lubricant, something. Tap magic. We don't have any tap magic, so we're just gonna use a tiny bit of 5W30. Which is better than
No, that's just dip spit.
just better than nothing. And so you just really want this to be as 90 degrees parallel to the hole as possible. And put some pressure on it and rotate. Try to keep it barely 90 degrees. And it's gonna cut the threads into the hole. The thing about taps, they're very strong, but they're very brittle. Maybe hard and brittle is the right word. So they're hard, so they'll cut through the metal, but they're brittle. So if you put any kind of sideways on it, you're gonna snap it in half in the hole. And they're very hard, so you're not gonna drill that bit back out. It's just a mess to get them out. That bottomed out right there. There's a chance that that may not be deep enough. We can give it a little back and forth so you get your threads good. Since we don't have a bottoming thread, there's a chance that we're gonna need to drill that deeper. Yeah, it's tapered, so like it doesn't start giving you the right size thread until like a bit down. Oh no.
How are we
Alright.
gonna get that out?
Well, we got 3 options. First option, take a flathead screwdriver, see if there's any edge left on that bolt, or hammer it and try to spin it, unscrew it. I already tried that. There's not enough edge left, and that screw is in there tight enough that it doesn't want to unscrew. So option 1, no. Option 2, we can get a Dremel and cut like a little slot in it, get the flathead screwdriver and just unscrew it. Go to option 3, which is take a small drill bit, drill right down the center of the what's left of that screw, and then use an extractor, which is spiraled the opposite direction, so when you go in reverse it tightens in there, and pull out what's left of the bolt after we drill a hole down the middle. That's the plan. Let's see how it goes.
Oh yeah.
All right, try it. any chance you can cut just a little slot in it without completely eating the whole thing?
Probably not. Maybe enough.
Yeah, that may be enough.
Nah, man, that's it, man. I don't know. That felt really tight. Just yeah, that's not gonna move.
Okay. Worst case, you just keep drilling it until there's nothing left.
Right. Oh yeah, that's dancing.
Okay, I think I drilled through it.
Okay.
Let's see if extractor needs to bite. There it is. It's biting a little bit. Oh man. No, that's not working. I don't know if the hole needs to be drilled slightly bigger. If I can really get this in there, get it started. Or if I just missed the screw enough that... Yeah, so we were able to get what's left of that screw out, but I think we jacked up some threads and everything too, so I don't know if it's gonna work.
It'll work.
I mean, it may hold. I mean, we got 3 others.
Right. Yeah, you know what they say.
You can't really tighten it down much.
You can
though.
drive your car on 4 lug nuts.
Did he say that?
Mm-hmm. Some guy somewhere said it.
Ah, okay.
Works for me.
Let's drill the rest of them the same depth. With the right height.
Yep.
Like when you don't like have the setup and like do this for a living, every little thing like takes longer than
yeah.
you'd expect. Like I just need to drill and tap 4 holes. Okay, well.
Like whenever like I do an oil change now, I'm like just put every tool out. Like yeah. Okay.
Let's try to tap it without jacking it up too much. Let's see if we can tap it without breaking a tap off in there. Yeah, it looks good.
Better.
Yeah, way better.
Cool.
It'll self-align a little bit, but not
Right.
like a lot of it.
It's kind of just the beginning once you get it going. It's,
Yeah.
My question is, when is it done?
Like if it
I
gets,
don't like it when I'm stronger than the tool and the tool snaps. There
yeah,
we go. Okay, that bottomed. I want to put this on a vise.
that's smart. Yeah, they make bottoming taps that don't have that taper to them.
Uh-huh.
They'll actually bottom
Like,
they'll
stop.
they'll give the threads all the way to the bottom of the hole, as compared to this one that's not threading near the bottom of the hole because it's got that point on it.
Right.
So I think you like start it with a tapered tap like we're doing now, and then you switch to a bottoming tap to get the last bit. Now it's a bottoming tap.
Son of a. I just want to see it move. That's all I want.
I think it's can't drill it out. Maybe I'll break it out. I don't know. It was at this point we decided, 3 mounting holes is probably fine. It's a little bitty motor. We're just gonna leave the broken tap in there, tap the rest of the holes, and rock out. Yeah, this will probably still tap the last 2 holes. There's a good chance it just cracks more, but that's way deeper. That's probably... way more threads. Okay. And this one's just ghetto, but we'll make it work. It's true. Let's just mount it.
I think we're good.
Woo! Boy, look at that. You give it a little... Oh yeah, yeah. That's plenty strong.
I mean, we could
Probably.
try to just get more here.
It could be plenty strong.
We'll find out.
We'll see how much we trust it once it starts spinning. We're duck and cover. At this point, you may be asking yourself, wait a second, Dust. What is the problem this time? The build seems to be going good. Well, you may or may not have noticed, Tyler's mic has died. He's kind of quiet. I'm boosting it during the edit, but it's going to sound a little off. And then my mic is starting to die. The sound quality is going to get it's getting a little crackly. Next time, we'll make sure they're fully charged. That's problem number 5. Huh? Yeah?
Motor time.
Yeah. Let's mount the motor. Let's get some of this metal shavings and dust cleaned up. And then we'll mount the motor. And we'll wire everything together. Later we'll wire it nice and actually put it in a control box. But let's just wire in everything and see if we can get the motor spinning.
Sound good.
Okay. Motor. Let's mount that. Yeah, it's already on here. Okay, tighten it down just very little. Motor attached.
Just shove those into the socket and good to go.
All right, DC motor, 12 volt or 24 volt. Motor controller. So let's give this 24 volts, give that 24 volts, and let's do it. Power supply. You give the power supply 110. No problem this time. We're just getting a little ahead of ourselves. Before we wire everything up, we need to drill a hole in our bracket for our RPM sensor so we can mount the RPM sensor to the side of the housing, drill and tap. So let's jump over there and let's do that first. All right. That's plenty of room for the magnet.
Not touching anything.
No, it's clear of everything. Yep, as long as there's enough space to drill and tap in there, and that looks like plenty actually.
Yeah.
Oh yeah, that's enough.
Yeah, we're good.
Okay.
Cool.
Nice. I guess punch and drill.
Well, this nonsense.
Trying to be incredibly careful. We've broken off enough drill bits and taps and everything else. I hate to keep interrupting the flow of the video like this, but you heard correctly. We did snap off a drill bit that you didn't see because we didn't think you wanted to see any more footage of us drilling holes. You were wondering why I was hand drilling it? Yeah, it's because we didn't have a good setup under the drill press and we broke a bit. If you see zoomed in right here, yeah, that extra hole got a drill bit stuck in it, or half a drill bit. But, carry on. We're trying real hard not to break anymore.
Could be worse.
Yeah, for sure. Hot glue the marker to tell you where you want it, or hot glue the magnet. It does have polarity, so you got to make sure you hot glue the correct side. Tyler already figured it out, and he marked the side that needs to get glued down. You do it upside down, the sensor won't read it. Oh yeah. Wonder if you hot glue where you want and then sit on it. Your hot glue gun makes some weird noises. Try to get that thing out.
Hobby Lobby special.
Cool. We can mount the bracket to the side and then get the sucker spinning. Woo-hoo. Water break. Making that belt's gonna be interesting. Because it said you just heat up both sides and squish it together. Oh, baby. To be continued. And 6 problems? Not so bad. Yup. Real nice and easy. Okay, we're at 3 RPMs. We're at 15 RPMs. 24, 30 RPMs. How we looking?